we're going to start the next unit. This unit is going to start in semester 1 and finish in semester 2. And our unit is going to focus on polygons, which are the shapes that you know. A triangle is an example, rectangle, square, pentagon, hexagon, so on and so forth. We're going to talk about those and the properties of polygons. And we're going to use our study of triangles from the previous unit to help us learn more about these polygons. Okay, so there's a lot on this intro sheet. I recognize that. So you may have to pause and spend a little bit of time copying this down. But the first unit the first lesson of every unit is going to be that way because there's some introductory vocab that we're going to need that spans the rest of the unit. Okay, so on the table of contents, we're covering 6-1, which is properties of polygons, and that's going to go on pages 56 to 57 of your notebook. The learning target on page 56 says, be able to classify polygons, be able to find measures of interior and exterior angles of polygons, which we're going to focus on right now. And then words worth knowing. So there are 4 words worth knowing, and then we're going to add some more to our notes just to make sure that you know some of the vocabulary that was previous to this class that it's expected that you remember. So we'll cover that in a minute. But a polygon, by definition, is a closed figure created by 3 or more segments. Okay, so a circle is not a polygon. So polygons are created by linear segments, and it has to be closed. So every point has to meet with another point, and where they meet is called a vertex. We're going to focus a lot on regular polygons in this class. So a regular polygon is a polygon that is equilateral, so all the side lengths are the same, and equiangular, all the angles are the same. So an example of a regular polygon for a quadrilateral or a 4-sided figure would be a square. So the square is the regular quadrilateral. And then you classify polygons as either being concave or convex. And I'm going to put a little star here by convex because that's what we're going to focus on. Okay, so I'll first talk about concave. So concave, basically, I mean, the definition says if a diagonal can be drawn outside the figure. So a diagonal goes from one vertex to another. So if I look at this vertex and this vertex, I could draw a diagonal outside that figure. Okay, I could always go from this one to this one, and a diagonal can be drawn inside as well. But because of the fact that one can be drawn outside is concave. One way, like the easiest way I think about it, is one of the vertices caves inward towards the center. If you think about the center of the figure, you have some that point inward and some that point outward. Okay, so if you have any that point inward that cave in, it's a concave polygon. All right, so the one that we are going to focus on for all of the things in this next unit are convex polygons. So those are the shapes that you know, triangle, rectangle. So here we have a 1, 2, 3, 4, 5, 6-sided figure, so that's a hexagon, and it is convex because all of those vertices point outward, but also every single diagonal. So if we start at one vertex, every single diagonal from that vertex is drawn inside the figure. It cannot be drawn outside. So that is definition of convex. All right, so you can go ahead and pause this and fill out your notebooks. Make sure you have those down. We're going to be using this vocabulary quite a bit. Okay, so you are going to need your new set of notes for today. So it's the blue packet, and we're dealing with polygon sum theorem. That's the very first page. You just fold it in half, and then you can cut along the dashed segment so that we have 2 flaps that we're going to open up. But we're going to actually start on the back side. And remember, I said there's some vocabulary from previous classes that you're going to need to know in this class. And it's the names of polygons. Okay, so names of polygons. So I just want you to have this so you can reference. Okay, so it has to have at least 3 sides. So a 3-sided polygon is a triangle. Okay, 4 sides is a quadrilateral. 5 sides is a pentagon. 6, hexagon. I know I'm going quickly through these. You may already know them and not need to write them down. 7 is either a septagon or a heptagon. Okay, so there's two different names for a seven-sided figure. 8 is octagon. 9 is nonagon. 10 is decagon. And then the only other one you really need to know is 12, and that's a dodecagon. Okay, so then when there's a lot more sides for the polygon, they're just going to call it an n-gon, where n is the number of sides. So like a 24-sided figure, which is going to eventually start looking like a triangle or like a circle at that point. But if you had a 24-sided figure, they'd call it a 24-gon, because they're not going to make you memorize names for every single one. But these smaller number of side shapes are used more often in applications, so we do have names for them specifically. All right, so that's just there for you if you need it. Okay, we're going to go to the front side. And I said we were going to use our study of triangles to help us figure out some of these things about polygons. So what we're going to do is we're going to look at the sum of the interior angles. Okay, so polygon sum theorem, this is interior angles. Okay, so we're going to start with a triangle because we know some things about triangles because we've been working with them quite a bit. So a triangle has 3 sides. Number of triangles. So what we're going to do is we're going to draw the shape. So in this triangle, there's only one triangle there, and all the angles of a triangle add up to 180, so the sum of the interior angles is 180 degrees. Okay. Now I'm going to shift colors so that it doesn't all blend together, and we are going to go to a quadrilateral, which is 4 sides. So I'm just going to draw a quadrilateral, so I'm going to draw a rectangle. And what we're going to do is working from one vertex, so I'm just going to put a dot there, we're going to draw the diagonals in. So this one we can only draw one diagonal in, but what it does is it splits it into 2 triangles. So there are 2 triangles within that quadrilateral, and I know that each of those triangles add up to 180. So the sum of the interior angles is 2 times 180, which is 360. Okay. So on and so forth. So we are going to keep going. So pentagon is 5 sides. It's going to kind of start getting squished in here. Okay. I'm going to go from one vertex. Doesn't matter which one. So here, this vertex, I'm going to draw a diagonal here and a diagonal here. Okay. So that separates it into 3 triangles, each of which are 180. So 3 times 180. And you can use a calculator. You'll want a calculator for this section, is 540 degrees. Okay, keep going here. So hexagon is 6 sides. Again, I'm going to go from one vertex, and I'm going to draw the diagonal. So 1, 2, 3 diagonals, which creates 1, 2, 3, 4 triangles. So each of those triangles is 180. So 4 times 180 is 720 degrees. Okay, so we could keep doing this all day long. We can keep increasing the number of sides. We can keep drawing the triangles and figure out what all the interior angles add up to. Okay, but we don't want to do that. We want to come up with a formula. So what I have here is an n-gon. Okay, so an n-gon has n sides. Okay, so whatever number is in front of that, that's how many sides it has. So let's look at the connection between the number of sides and the number of triangles. Okay, so here, that's 1. So if I have 3 sides, there's 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. So notice how the number of triangles is always 2 less than the number of sides. So this is going to be n minus 2. Okay, and then the sum of the interior angles, I take the number of triangles and I multiply it by 180. So this is just going to be n minus 2 times 180 degrees. Okay, so that gives us a formula here. So here, this is only for convex polygons, because again, those are the ones we are working with. But the interior angles, the sum of the interior angles is found by n minus 2 times 180 degrees, where n equals the number of sides. Okay, All right, so we just use this chart as a means to derive that formula. Whenever we're given formulas in this class, I like to kind of show you where they come from instead of just having you memorize them, because if you memorize them, you will likely forget it. And if you forget this one, you have a means to go back and figure it out. You can always draw the figure, draw the diagonals in, figure out the number of triangles, and multiply that by 180. Okay, so we're going to open up this part, and we're going to do some examples. Oops, my pen went through. It says the example, find the sum of the interior angles of, and the first one is a convex octagon. Okay, so convex, again, that just means all the vertices point outward. That's good. That's what we're going to be using for this one. And an octagon, the number of sides is 8. Okay, so sum of the interior angles, I'm going to do n minus 2 times 180 degrees. Oops, my pen is dying, so I'm going to switch colors. Where n is 8, so this is going to be 8 minus 2 times 180, which means there are 6 triangles in an octagon. So 6 times 180 degrees, and I would do this on a calculator, is 1,080 degrees. So no matter what the octagon looks like, as long as it's convex, is all 8 of those angles are going to add up to 1,080 degrees. Okay, let's do the second one here. Regular nonagon. Now here has the word regular in it. Okay, so regulars are always going to automatically be convex. Okay, but irregular means it is also equilateral and equiangular. Okay, so that means when this nonagon is drawn, those 9 sides, all 9 sides are exactly the same length, and all 9 angles are exactly the same. Okay, so let's figure out what all those angles add up to. We're going to do the n minus 2 times 180, and in this case, a nonagon is 9 sides. Okay, so if I plug 9 in here, I get 7 triangles, so I'm just plugging the n in here, so 9 minus 2 is 7. So 7 triangles times 180 degrees is 1,260 degrees. Okay, so that's what all of them add up to. So as you add a side, you are adding an additional triangle, so it's always going to increase by 180 degrees. Okay, this one has a secondary question. It says, what is the measure of each angle? Okay, so because we know that it's regular, okay, because we have that extra information, we can figure out the measure of each angle because they are all equal. So I know all the angles add up to 1,260, so I'm going to divide that evenly by 9 angles. And that means each angle is 140 degrees. Okay, so if it's regular, and only if it's regular, every single interior angle of that regular nonagon will be 140 degrees. Okay, one more example for interior angles. So you're going to have ones where you have to set up an equation and solve for a variable. So with these problems, you have to determine what the interior angles add up to first. So I have a quadrilateral. So you can use the n minus 2 times 180, or because it's a quadrilateral, right, we have it on the front here. So a quadrilateral is 4 sides. It's going to add up to 360 degrees. Okay, so the interior angles are all going to add up to 360. So here I have 4 angles here, and I know the sum of them adds up to 360. So I'm going to use that equation. I'm going to do C plus 3C plus C plus 3C equals 360. So I'm taking all 4 of those angles, adding it up to 360 because it's a quadrilateral. Okay, now I'm going to go ahead and solve by combining like terms. So I have 1C plus 3C is 4C, plus another C is 5C, plus 3 more is 8C, equals 360. And then I'm going to divide both sides by 8. And I get that C equals 45 degrees. Again, using a calculator. I don't expect you to know that off the top of your head. Okay, now for this problem, they want us to find the measure of each angle. Okay, so I know C equals 45. So I want to find the measure of each. So I want to know the measure of angle P, the measure of angle Q, the measure of angle S, and the measure of angle R. Okay, so what I'm going to do is I'm going to plug C in. So here, P is the same as C, so it is 45 degrees. And same with R. Those are the same, so 45 degrees. Then Q and S are 3 times 45. Well, 3 times 45 is 135. Okay, so these are each 135 degrees. All right, just like that. Perfect. All right, so we are going to now move to exterior angles. Okay, so you'll have different problems just like this. So if this were instead a quadrilateral, a pentagon, then you would change to what all the angles add up to. So you have to be flexible and change depending on the figure you are given. All right. So here's what I normally do with exterior angle theorem here is I take a couple different figures. So notice how I have this triangle here, okay, is my polygon, or I have this pentagon, showing that it doesn't have to be regular, right? It doesn't all have to be the same length. And I created the exterior angle. Angles are created when you take a side and extend it out. So, and then you just keep going in the same direction. So if you take each side and extend it out, it creates an exterior angle. So what I normally have you do is take a calculator and go ahead and add up all the exterior angles of that triangle, and go ahead and add all those exterior angles of a pentagon. Okay. So you can go ahead and pause the video, add them up, and see what you get. Okay, so hopefully you found that they both add up to 360 degrees. All the exterior angles of either figure adds up to 360 degrees. And that's not a coincidence. Okay, exterior angles will always, no matter how many sides a polygon has, the exterior angles will always add up to 360 degrees. Now, if you think about it, if you keep increasing the number of sides, okay, then that polygon is going to look like a circle. So if you had like 100 sides on a polygon, it's going to basically look like a circle like this. Okay, so I'm just going to, I know this isn't exact, but okay, so imagine those are all connected, right? If I started drawing in the exterior angles, they'd start being so small, and they would just wrap around that circle, okay? And see how the exterior angles would basically be a circle, and a circle is 360 degrees, okay? So no matter how many sides your polygon, exterior angles of any convex polygon will equal 360 degrees. Okay, no matter how many sides you have. Okay, all right. So these ones are easier than the interior angles because you don't really have to figure it out. It's always 360. Okay, so we're going to look at how that makes sense, so you can see it a little bit better and use it to solve a problem. Okay, so find the measure of each exterior angle of a regular hexagon. Okay, so first thing I'm going to do is sketch out a regular hexagon. I'm going to try. Okay, so a regular hexagon has 6 sides, and I'm trying to draw it so that every single side and angle is congruent. Okay, so this is where I tell you, like, let's use your imagination, and we're just going to give ourselves some grace, and I'm going to imagine that every single one of these sides is congruent, right? Which makes every single angle the same because it is regular. Okay, so regular hexagon. So I have 6 sides. All right, so we know that exterior angles add up to 360. Okay, and so I could draw those. Okay, so every single one of those exterior angles would add up to 360, and they are all the same if it's a regular figure. So I could just take 360 and divide it by 6 to get 60 degrees. So that means every single one of these exterior angles is 60. Okay, now I want to show you how sometimes finding an exterior angle makes finding an interior angle of a regular figure so much faster. Okay, so remember how we did the interior angle of that regular nonagon, and we had to find what they all added up to for interior, and we divided by 9? Okay, so let's say I wanted you to find the measure of each interior angle of a regular hexagon. Well, what you can do is you can look at how this interior angle, so like if I just say it's x, right? And this exterior angle are always along a line, okay? So they are always a linear pair, which means that they add up to 180 degrees. These two angles right here would add up to 180. So then I could just go, okay, 180 take away 60 is 120. Okay, so every single interior angle here would be 120 degrees because it would be a linear pair with that exterior angle. Okay, so I sometimes think it's easier to find the interior by using what I know about the exterior angle. Okay, but you could do it either way. All right, here we go. Last problem. Okay, so here I have a pentagon, kind of like I did at the front of the notes here. Okay, and it says find the value of x, then find the measure of each interior angle. Okay, so they want me to figure out the measure of each interior angle inside. So first we're going to find the exterior angles, use that to find the interior. Okay, so I know the exterior angles add up to 360 degrees. Okay, doesn't matter how many sides, so they always add up to 360. So I'm going to set up an equation because these are not all the same. Like the other example, these exterior angles have different measures. So I'm going to add all of these x's up and set them equal to 360. So I'm going to do, I'll start here, 2x plus 7x plus 2x plus 3x plus 6x equals 360. And I'm just going to make sure I didn't forget one. So this has 5 sides, so there's 5 exterior angles, 1, 2, 3, 4, 5. Okay, I got them all. Now I'm going to add up I'm going to combine like terms. Okay, so 2x plus 7x is 9x, plus 2x is 11x, plus 3x is 14x, plus 6x is 20x. Okay, so I combined all these like terms, so 20x equals 360. I'm going to take and divide each side by 20. Okay, and if I look here, the zeros cancel right here, and 36 divided by 2 is 18. So x equals 18. So what I'm going to do is I'm going to use a calculator and plug 18 back in to find each exterior angle. So 2 times 18 is 36. 3 times 18 is 54. 6 times 18 is 108. 2 times 18 is 36. And 7 times 18 is 126. Okay, so just using a calculator, plugged it in. Then I'm going to use that idea of the linear pair. Okay, so I know that the exterior and the interior angle always add up to 180. So I'm going to use that to find the interior angles. So for this 36 degrees, I'm going to do 180, take away 36, and that gives me 144. This one was also 36, right? So the interior angle here is also 144, since those ones were the same. Okay, so this one right here, the exterior angle is 54. So 180 take away 54 is 126. This one's 108. So 180 take away 108 is 72. And then this last one, 180 take away 126, is just the opposite of this pair, is 54. Okay, so there you go. I have the measure of each interior angle written in pink here. And again, I use the exterior angle being a linear pair with the interior because they add up to 180. All right, so I know that was a lot of information. I think you guys will do fine with it. I am here to help you. I will help you in class. If you have any questions, make sure you put them down on a sticky note so that you can ask me in class. All right, I'll see you guys soon.